Very good, Chris, to go.
All right, let's do this. Okay. Okay, my name is Chris Esplin. I'm a Firebase developer, Google developer expert. I've been doing Firebase since 2013, and yeah, I develop everything on Firebase if I at all can. So what I'd like to do is I'd like to walk everyone through some Firebase features and just do a quick overview. This will go a lot better if I have a lot of feedback. So the more I hear from you folks, the better. I'm interested to know what you'd like me to cover and what questions you have as you have them, and I'll be responsive. And I usually have done this in front of live audiences, live classes. So it's a lot easier to just sort of read the room and connect with people and figure out what I need to be talking about. So the degree to which you guys can message me, be on the chat, chime in on voice even, that's fine. That would be fantastic. So let's just start off with a quick explanation of what Firebase is. Well, shoot. Have any of you used Firebase? Anyone want to chime in? Yep, good, lightly, awesome. Okay, got a couple. Cool. Thank you. Okay, so let's go high level and then try to dig deeper, and then you guys can help direct me which direction you want to go. Because Firebase is actually a really big product now, and we don't have time to go over everything in depth, so we're going to pick a few things to focus on. So Firebase is fantastic. It's an application development platform, originally for web. Now it's really big in the Android and iOS worlds as well. Google bought them in, I think, end of 2014. And so, yeah, they've really grown under Google's, funding. And Google has started to roll a lot of their large Android and iOS projects into Firebase. Not so much the web, more Android and iOS. I know we're a web group, so I'm just going to cover the actual web stuff. So the way you get started with Firebase is you hit console.firebase.google.com, or I think you can just go to firebase.google.com to do that. Click Get Started, and we're there. Now I have a lot of accounts, so I've got to pick the right one, or you're not going to see my demo accounts. Okay, and you make a project for yourself. You name it whatever you want. It's got to be unique, and there we go. I'm going to go to, let's see. I'll pick one of these in a minute. For now, I need to start off with a demo of what Firebase can do. So you guys are welcome to follow along on glitch.com/windshrimp. Can you guys see that? Wind shrimp. I'm going to paste this in there we go. Wind shrimp. So Glitch is fantastic. It's a little place you can do sketches, sort of do some light programming. I've actually tried to do a little heavier programming on it. It's difficult to do, but this kind of stuff is perfect for Glitch. And so you can click the show button right there to pop it up into a new tab, and you get to see this running application. This whole app here is going to be running in this window. All right. So you guys are free to log in and chat. So log in with Google. I'll log in with one of my many accounts. You guys, hey folks. There we go. So the whole point of this is I want to show you a live project you can work with. And this is an instance of a project. You can go through all this code, see exactly how it works. It's all in just some really basic React with some, hi, William.
Oh, shit.
If you click on manage participants, you can.
Okay, so let's see how this is working. So this is How to Firebase Tutorials. This is the project. So I'm going to open up my How to Firebase Tutorials project. And I think I have someone else. Okay. React Chat, default chat room. So you can see all that data that we're chatting. You can add to it. Okay, so I got a question from Samarvir, and I'll answer that in just a minute. Yes, but we definitely did answer that question. Okay, so Firebase has these main pillars for web. I actually haven't used MLKit. I think that may be an Android thing. But authentication, you have the original real-time database over here, and then Cloud Firestore, which is the new kind of real-time database. Storage, which is where I store all my images. So all these images you can see here. And they have a whole hosting system. So I host my apps here as well. And then finally, Firebase Functions, which is what makes Firebase truly serverless. So I've got a hello world function here that lives outside of any server that I run. And so I can run Node.js code in the cloud one function at a time. So I wrote a function called hello world that just returns hello world. Let's see if this works. This ought to work. There we go. This page is generated using a cloud function with an HTTP trigger. So you can set up just a single function and have it accessible to the entire world. Okay, so I'm going to go into, hey, got some friends. I'm going to go into how I built this. So the first thing, the way you start off is you have to add a script tag that adds each piece of Firebase. So Firebase app, and you can actually, there are a couple options here. I'm just going to go over the way I did it. And so I added auth and the database for the real-time database. And then I added an initialization script. So that just initializes it and gets it live on the page. Okay. And when you click login, all I got to do to log you in is call Firebase. This is a on the window object, window.firebase.auth.Google auth provider. So I make a new auth provider. And I call firebase.auth, sign in with pop-up provider. That is literally all I have to do to sign you in. So right here, when I want to sign out, it literally just calls firebase.auth, sign out. And we can prove it if I can get this thing to work. There we go. So I can put breakpoints here. I can sign out, and you can see it stops right there. And signed out. Okay, sign in with Google. You see it stops right there, and it pops it, and I can sign in. And what that does is that gives me an entry over here in the authentication table. So a lot of anonymous users. Let's see if I can find one at chris@christopheresplin.com. Nope. Huh. All right. Well, I'm logged in somehow. Have to figure that one out. Here we go. Okay, so we're logged in. And the nice thing is, let's see if I can get in here to index that. Nope. Got to find in functions, chat list, chat wrapper. There we go. So to keep track of what the user is on the page, I have a firebase.auth on-off state changed, and it just spits out my current user, which is also known as a JWT. So I'm going to console log out the JWT. There we go. Okay. And I'm going to refresh the page. And it automatically logs me in. Especially if it's working. Come on, folks. On-off state changed. Let's find on-off state changed here. And we can just put a listener right here. My changes don't seem to be propagating correctly. So the current user is this guy right here. This is what's known as I think it's a JSON web token, a JWT or a JOT. And this is how a lot of websites do their authentication. So when you log in, Google mints a JOT and gives you that JOT. And it pops up through this on-off state change listener. So every time you refresh the page or hit the page, it'll start listening. And if there is no user, if I'm signed out, then the current user will be null. So I got a null current user. Now I'll sign back in. Sign in as a different user this time. And I've got my new current user. There we go. So you can see this user, and I've got a lot of this is garbage data that I can't actually use, but we can use a little bit of the provider data. So you can say the providers, it's coming from Google, provider ID is google.com. I've got a photo URL that'll show you a little photo there. And my name, an email address. This one doesn't have an email address. Yeah. Okay. Anyway, so that's the basics of Firebase authentication. There are a few other ways you can authenticate. So we've got sign-in methods such as email and password, a phone, Google, play games, Facebook, Twitter, GitHub, and an anonymous auth. Right now, I just have these three enabled for this project. Okay. So once I'm logged in, once I've got my JOT, I can feed that into my app. So I take it and I set state here. So now my current user, my app now knows about the current user. And if there's no current user, I'll stop listening to messages. But if there is a current user, I'll listen to the messages. So check this out. So to listen to messages, I make a message handler. And it's this.messages query on child added. And let's get the messages query. So this messages query is firebase.database with a ref. A ref is a string that is any path to data. So in this case, it's authenticated React chat room. So over here, if we go to the database, this is the real-time database we're talking about, not Firestore, the real-time database. And we will talk about Firestore in just a minute. So you'll see authenticated React chat, and then default chat room is the name of the room. Oh, there we go. Nope. There we go. So that would be default chat room, which you can see right here. And then I'm just saying I want to limit to the last 50. So I only want the last 50 messages on the queue. So you can see all these messages that are stacked up. I'm only going to get the last 50 of them, reading from the bottom up. And they'll fire on child added. So I'll get all that data coming in, each one individually as a snapshot. I'll take each message received, and I'll tack it on to, I'll push it onto the messages list and set state for messages. And that's how we're getting these messages to flow in. So let's do another message. There we go. All right. We can even see it running here in, I guess we saw message received. So display name, message, photo URL, UID, display name, message URL, or message, photo URL, UID. So it's really that simple to get data out of the database. When you're done listening, you say messages query.off, child added with the message handler, and it just stops listening to it. So let's talk about how we add it in. So if I want to add data to it, add a message. I take the current user in the room, and I say firebase.database ref. So I'm getting that ref again, which is that path to the room. Again, that's authenticated React chat default chat room. And then I call push, and I can push data onto it. So every time I push data, the UID, email, display name, photo URL message goes up as a new message. And that is the basics of how this works. Yeah, Okay, does anyone have any quick questions beside the Firestore? So I will get to Firestore, I promise. I know this is kind of a lot, kind of fast. I'm trying to cover as much ground as possible in a pretty short time span. Okay, so this is the old real-time database. What this thing excels at is very fast, very small updates. So you can use this for chat. It's perfect for chat. It's like the perfect backend for a chat app. Because I was able to spin up this chat app with almost no work. Like there was no work on my end, and I have a real-time chat app that can be shared around the world, and of course in real time. So message is, let's go back to message. You mean this message? Message right here? So every time I want to get an instance of the database in the wrapper, oh, chat wrapper, there we go. Chandler message.snapshot. Oh, okay. This is called a snapshot. Yeah, there are, okay. Yeah, there are definitely functions and limitations. We'll show you those in a minute here. So what happens when you get a snapshot is an object that lets you pull data off of this instance. So the snapshot represents this endpoint right here. So one of these endpoints, any endpoint. And you can pull data off it. You can also pull the ref. You can be like, hey, const ref equals snapshot dot ref. Because every node can be its own ref. So I started off creating a base ref with this database.ref, but then I can make new refs off of that. I can say, oh, ref dot child message text. Message text ref. Then I can build off of, say, message text, and then I would have a new, let's say, message text. Hey folks. There. So if I refresh this, I get the messages received. The second to last one has message text now. And here's the thing you got to pay attention to. It's totally arbitrary. Like you can add whatever data you want, wherever you want it, however you want it. There's no structure to this at all. It's just a big JSON object and a way to access it. So you got to be real careful. And that's where we're going to have to talk about Firestore in a minute, because Firestore is sort of the grown-up version of this. Firebase is awesome because it's super, super flexible and powerful at what it does. But it has some big limitations that come along with it. Also, it's really easy to make big mistakes with it because it's just dangerous. So I really like it. And when you know what you're doing with it, you can be very powerful. But it's tough to get started with. Okay, so you said message query. Oh, messages query right here. Yeah, so what this is, so messages query is, it's literally a query. So you take an instance of the database and you make a ref. The first thing you always have to do off a database is make a ref. But then you can have optional query steps like here. So I can say limit to last. I can say limit to first. And there are a few others that you can find in the docs. I actually have a website on this. It's called fullstackfirebase.com. And it has all of this and actually a whole lot more. And I'm working on a course, which I can give you guys access to that course. So let me find that real quick. Let me pull this up. There we go. Password, Firebase. So you guys can get in here and you can watch my entire course. I'm not quite done with it. There are a few videos missing at the bottom, but I'm working on it. And you can go through the entire thing and learn as much Firebase as you could possibly consume. Like this is a lot. And it uses these glitches. And of course, I've written up as much as I could here as a sort of an ebook. And I may have to go back and edit this a lot to make it sort of relevant. So there's some missing There are these notes. These notes are really helpful in each section. So you can go through and say, oh, I want to work with Firestore. Well, these are the things you actually need to know to use Firestore. So if you just read the notes, you'll actually have everything you need. And then I've got whole outlines on all this. So yeah. Okay. Yes, you need to real-time Firebase messenger course like back in the day. Seriously. Okay. So the ways you mess this up is your data structure is very sensitive. You can destroy your performance if you nest data too deep. So the primary way people mess this up is they nest their data too deep. You don't want to nest it deep in the real-time database. You want everything to be shallow. Lots and lots of nodes, but shallow. So you can have a ton of data in each node too. You just don't want to nest nodes too deep. Like this is about as deep as I'll ever nest. Authenticated, React chat, default chat room. That's like 5 deep. That's as 1, 2, 3, 4 deep. That's as deep as I'm going to go. So these guys, they don't have children. Because the problem is you can't query just the children. You always, if I wanted to get all the messages, I have to query all of the data under default chat room. I can't say just give me the messages. So because I can't do targeted queries deep into objects, you have to get everything. And that's a big problem. And so I went over that in full stack Firebase. You can definitely see ways to work around that and how we make that work for you. So this brings us to really important, the first question, which is Firestore versus Firebase. So now we have two things. We have real-time database, which I just showed you, which is very good for small, fast, light transactions. So light data back and forth really quick. Firestore is kind of a different beast. Firestore is in a way like a lot more powerful, but way more structured. So it's kind of more structured data. You have collections and you have documents in those collections, and that is how it lives. It's always a collection, then a document. A document can have sub-collections, which can then have their own documents. So you can have sub-collections in a document, but it's always document, collection, collection. Or sorry, collection, document, collection, document. So for example, right here, let's say I've got a document called salaries. Salaries has a sub-collection called employees. Employees has a document, and then they've got fields. So it's very, very structured. What this allows Firestore to do is to be extremely performant over massive data sets, which is actually something that Firebase, the original real-time database that I just showed you, does not do well. It does not perform well over large data sets. This thing performs well over any data set. It scales based on the size of the query that you're requesting. So if you have 5 results, it doesn't matter if you have 10 million records in the collection. It's just as fast for those 5 results as if you have 10 full results in the collection or 10 million, the 5 results take the same amount of time. So it scales really linearly with the size of the request. It doesn't scale really with your data at all. It's just very, very fast. But it has to be structured to achieve that. So I build everything in Firestore now, except for chat. Chat is still in real-time database because it is better for that. But I build everything else in Firestore. And I have a whole walkthrough here on Firestore that you can go through. Well, there's a video on it, and I've got a glitch that shows it, and I've got a whole project that shows it too. Okay, so I'm going to go answer some questions. So yeah, so Firebase is both dev and prod. You can use Firebase in development and in production, same with Firestore. They're both totally production worthy. Firestore is officially in beta. So, a little word of warning, I wouldn't take it to a really big company and say, let's use this. Firebase has been out of beta for years and years. Firebase is totally frozen. It's exactly what it's going to be. And they're supporting it because a lot of people use it still. And it's very, very good for short, quick transactions. It's very fast for that stuff. You pay in part, I should talk about how you pay for these things. So you get charged for Firestore based on how many records you query. So if you query 100 records, you're charged for 100 records. Doesn't matter if you query them one by one or whatever. Every time you query 100 records, you're getting charged for those 100. Now it's like 6 cents per 100,000 records. So it's really cheap, but just to think about it, you have to think about it in that way that you're getting charged per record. Whereas in in the real-time database, you get charged based on the bandwidth. So if the records are really tiny, you can have 1 million records. It doesn't actually care. It just cares about how big the records are. That's why it's really good for small, fast, lots of reads and writes, because you're not getting billed for every read and every write like you would on Firestore. So that's the main reason I make a decision for one versus the other, is based on the billing structure and just the performance characteristics of fast and light versus heavier and structured and like really queryable, really powerful. Because you can't do lots of queries in Firebase. Firebase is actually really limited. Whereas Firestore, you can do some pretty sophisticated queries and pull stuff out of these objects. Okay. All right. Is Firestore schemaless? Firestore is schemaless. You can save whatever you want, wherever you want it. It's entirely up to you what kind of data you save, which is why I wrote a course on it, because you can mess it up if you save your data incorrectly. For example, with Firestore, sub-collections thus far, they exist. You can make a sub-collection on a document. We haven't found a good way to use them yet. So we actually don't know, like the Firebase, Firestore community, I've not seen anybody use it well. They're actually really limited, and I could kind of say use case for them, but I don't actually use them at all in any of my own stuff. I found them to be very dangerous because they have these limitations. And if you don't know what the limitations are, you realize you can't query them very well, and it's a problem. So yeah, it's schemaless, which again is programmer beware. Learn the data structure and the data model before you drive into something big with this, because you can definitely run into dead ends if you don't know what you're doing. A Firestore similar to Mongo, kind of. It's a document collection database. So like Mongo, but it's different in that it's hosted by Firebase, by Google. You can't host it locally. You pay for each transaction, you're not paying for server time. And it scales really nicely. So the point of this, the whole point of Firebase, and I should have probably said this at the beginning, is that you can do a demo app in Firebase. And then if 1 million people hit my Firebase chat app, it's going to perform about the same. So it doesn't really matter how many people are on it, because Google built this infrastructure to scale forever. And especially with Firestore. Firestore, if you write it correctly, can just scale forever. So you can write your MVP, your minimum viable product, on top of Firestore. And if you ever have 1 million people, 1 million users, Firestore doesn't care. It's like, this is nothing. We're ready for 100 million. Bring me 100 million. Then we'll start to talk about actual scaling problems. So you could run very large businesses off of Firestore, no problem. It's a Google product. It's meant for sort of their planet scale deployments. So you can't really run out of headroom on it. And you don't have to worry about uptime or managing it. They do it all for you, which is why I do all of my development, my freelance stuff on top of Firebase, because I don't like spending time writing servers and maintaining databases. So yeah, I use this as my primary backend. I have for the last 4 years. I built calligraphy.org, which is my business. I built that on top of the original Firebase. I'm building new apps now on top of Firestore. It's definitely a learning curve versus SQL. If you come from a SQL background, this is going to be a little different. That's another reason I got the course. You really have to read up a little bit before you dive in. If you are carrying a lot of SQL baggage with you and try to structure stuff like you do with SQL, you'll likely be disappointed. It's a different data model. Okay. So there is no ORM. You don't need one. I've played around with them before. Some people have tried writing them, and I've found them all to be a little disappointing. Even the ones that the Firebase team releases, I don't think they're as good even as their native SDK. So I just use the native JavaScript SDK. Like this stuff you see here in Chat Wrapper. This is how I write my apps. I just attach and get it. Now if I'm writing a big production application, I'll extract these listeners into their own files, into their own services. So I have a service that listens to each object and can listen and unlisten. I'll actually wrap them up in something called RxJS, which handles data streams. I'll do a little bit of that myself, but you don't need an ORM or any sort of structured thing to make this usable, because it is built literally for JSON and the web. It's all just exactly, it's transparent. Okay. Yeah, you could use Rebase. Tyler McGinnis used Rebase. I think he wrote Rebase. I've never used it. No Reddit hug of death. I am not familiar with the hug of death. You definitely, I mean, now I got to research. What is the Reddit hug of death? Oh yeah, no Reddit hug of death. Yeah, it's built for the Reddit hug of death. So bring it on, Reddit. Hit me. Okay, you can architect it poorly, and if you architect it poorly, you can actually build in some limitations. But if you sort of follow best practices and the stuff I've set out in this course, you won't. Don't get too fancy. If you stay simple, it'll be just fine. Is it more like GraphQL? I love GraphQL, by the way. GraphQL is fantastic, and GraphQL really, I think I actually have. I've written a GraphQL. I put GraphQL in front of Firestore, used Firestore as the underlying database, and pulled the data for the GraphQL query. GraphQL is really just a way of exposing an API to the world. So you can back GraphQL with whatever database you want. SQL, with Redis, with Cassandra. Pluralsight, we use a lot of Cassandra and SQL, Postgres, to back our GraphQL. If I were doing this, I'd back GraphQL probably with Firestore or with, actually, I might even do it with Firebase. I don't know. I haven't thought it through all the way. It really depends on how your data structure, what kind of data you want to expose via GraphQL. But you can definitely use GraphQL. You can even use GraphQL and deploy the endpoint into a cloud function so that Firebase hosts your GraphQL as well. So we can host GraphQL in a cloud function so you never even have to touch a server. Okay. Would you recommend Firebase Firestore for a bunch of, how would you say, students who are about to embark on a 30-hour hackathon on their back end? Yeah, actually, that's kind of perfect. Firebase got their start doing hackathons, doing prototypes. A lot of people still use Firebase mostly for prototypes, and for production, they'll roll it into they'll hand the prototype to their backend team, and the backend team's like, oh, we know SQL. We're doing this in SQL. So they'll just do SQL. And that's a really common pattern. I don't like it because I think you should just stay with the original data structure from the prototype, but that's just me. Anyway, yeah, you can, it is perfect for this. It depends. If you're really, really fast with SQL, you may have to learn a little bit of this before you can sort of match speed. Maybe a while before you match your same productivity level. But if you're not really experienced with SQL, I'd say just dive into this. No regrets. You'll be fine. Yeah, the data model in Firebase is document collection. So more like Mongo. Yeah, it's a different mindset. And I've tried to write some stuff up on that on fullstackfirebase.com about how that's different. The idea is so each page, it's really nice if each page can be represented by one document. So you'll have your list of things, and that can be your collection. But when you click into a detail view on a page, it's really nice if everything you need is just in that object. So unless you have some really deep nesting problems and really big data, I try to sort of match my data structure to the views in the app. So if I have 3 different kinds of view for a certain object, I may copy it 3 times. I may have that doc exist in 3 different collections. I have like a collection for each kind of view, and then have that doc copied 3 times. Like, you can do that because then you only have one, you don't have to do any joins because you can't do joins. So then you just say, oh, hey, I want this kind of document in this format or this format or this format. And you can save it in all 3 and just request the one you want. The idea being, you don't really write joins. Now you can use shared keys. So you can take a key and say, hey, this key is the key for, say, my user. Now, my transactions are going to be transactions / the key. The logs for when the user logs in could be log / that user key. So then you can take that user key and reuse it all over the place. And then you can kind of fake a join, because you can say, hey, give me the user's logs, the user's transactions, the user's payments, the user's messages. And you can make 4 individual queries and then join them on the front end on your client app. And so that's how you have to do joins, is you can use shared keys to do that. Yeah. Okay, does the auth plugin only work for Google or Facebook, Reddit, GitHub? Yes. It works for Google, Facebook, Twitter, GitHub, not Reddit. Email passwords, so just generic. You can do a custom auth. So if you already have an existing auth system, you can mint an auth token. You can take your own custom auth token, send it to Firebase. They'll give you back a Firebase version of it, which you can send to your client. So both go to your client, and the client can authenticate with the custom token, the custom Firebase token on the client. So then it can talk to the database after that. So yeah, big difference from your normal SQL Express APIs is your client apps talk directly to this. I don't know if I made that explicit. They talk directly to the database. They don't go through any API. You don't write an API on top of Firebase. You just talk to it from your client app, which saves just untold man hours. I got a programming test in Pluralsight for a job before. Yeah, it's a tough one. It'll get you. Okay, functions. Okay, back to functions. So functions is kind of, to me, functions plus Firestore are the two killer apps for Firebase. Storage is awesome too. Storage lets you upload files directly from your client directly to a Google Cloud Storage bucket, so you don't have to write a server for that. So writing servers for file uploads is misery. I've done it a bunch of times. Hate it. Never doing it again. I upload directly from the client using this. Hosting is really simple, like super simple. Just read the docs on it. You can host no problem. It's seriously like a 10-minute thing. I already showed you authentication. I showed you the two databases. Okay, functions is killer. Functions lets you run individual Node.js functions in the cloud. And what they will do is they will spin the function up, run it, and spin it back down. So if 1 million people hit my hello world endpoint, they will spin up 1 million functions, fulfill 1 million requests, and then spin them down. So I will pay for those 1 million requests only. So that Reddit hug a death problem just goes away, because if you get 1 million requests in a minute, Google's like, we're Google, we don't care. Here are 1 million functions. Bam, done. So like a function like this is just ridiculously scalable. Now the question then is, how do we trigger these functions, and how do we write these functions? What do they look like? So these functions trigger a lot of different ways. You can trigger them based on changes in the real-time database. You can trigger them based on changes in Firestore, changes in your storage buckets, changes in authentication, so user created or user deleted. You can also do them with HTTP requests, like Express endpoints, like Node.js Express endpoints. So this Hello World is an Express endpoint that I just mounted to Hello World. All right, so let's look at one in action. Here's a stats. This is keeping track of the stats. So actually, I don't have it deployed. Well, it's not working right now. I don't have it deployed. But if I were to deploy it, it would keep track of the stats. And the stats, let's hop over here to the real-time database, look like this. There. This was when there was only one user and only one message, and I wrote it. So I was just testing to see if it worked. So I haven't deployed this. I've been using this project for a bunch of different demos, and so the last one I did was the Hello World demo. So I haven't deployed this one. But what this one does, let's go here to functions/index.js. I pull in Firebase functions. I pull in my function, and then I mount the function. So I have to export it. So exports.stats. So it's going to go to stats. That'll be the name of the function. And then I'm doing firebase.database.ref, and I'm attaching it and mounting it to authenticated React chat room with any room and any key. So these are now wildcards. And then every time anything gets created, I'm using the onCreate handler, it'll run my function. So every time you make a chat, it'll run stats. So let's go to stats. It gets the snapshot, which is what you saw before, and then a context object, which has like the parameters, the room and the key, which we saw back here, the room and the key. So I get the snapshot for the piece of data that got added, and then I get the parameters that came in from the mount point, and I can build off of that. Also a timestamp. A timestamp off context as well. So context.params gives me the room and the key. Context.auth gives me the UID, because we're authenticated. And so I have an auth object with the UID on it. And then snap.val, kind of like snapshot.val, kind of use them interchangeably, snap and snapshot. That gives me the data for the endpoint, which in this case is a message. Then I can run whatever code I want. And all I have to do is return a promise. And that just tells the returning the promise just tells Firebase functions to wait until all the promises are fulfilled before spinning down the function. It's just telling it to wait. Otherwise, if you don't return a promise, it'll instantaneously spin down the function and all your code will go dead. So as long as you return a promise and you have an idea of what you can get off of this, this event, you can do all kinds of work. So in this case, I'm making 2 promises, a stats promise and a user stats promise. I'm doing a transaction, which is kind of an advanced Firebase feature to increment a count, increment a counter, and set a last active timestamp and a last message timestamp. And when both those transactions are finished, my promise.all resolves and we're done and we have stats. Limitations to functions. Functions have what are called a cold start time. Okay, so there's a cold start and a warm start. If a function's been running a lot, then Google's underlying infrastructure will have an instance of it. It's kind of warm, kind of waiting for requests to come in. And it'll just be fulfilling them, like really, really fast. But if a function hasn't been running for a while, they'll shut it down and put it all the way down into sleep mode. And they'll sleep it. They'll take the infrastructure out. So when it gets a new request, they'll be like, oh shoot, we got to spin the infrastructure up. So they'll spin up a container for the function. And it can take a few seconds sometimes to spin the container up. And then it's warm, and then they fulfill it. So the limitation with this is you have to build with the understanding that some of your requests may be slow. Once it spins up, they're fast. But there are times where you have to, some loads need to always be warm, always be fast. And then you can't use functions for that. But the vast majority of things that we would work on, it's not a problem. So let's look at the functions dashboard. So I've got this hello world function right here. We can look at the logs. Apparently the logs are cold too. There we go. So we can see that a cold start on that took 300 milliseconds, 330. That's actually not so bad. So that's pretty impressive. So I can hit it again. It's a little slow. Don't love how slow that is because it probably went cold again while I was waiting. Let's just force it to refresh. The logs can be slow to show up, so you kind of have to be patient with the logs. Look, I ran stats March 20th. So this last one took 329. So let's hit it again. That was much faster. The log will show up in a minute and we'll see some nice low number. So that's kind of how this works. Yeah. There we go, 4 milliseconds. That's fast enough. So yeah, they've worked really hard to get these speeds down. This is a high priority for the functions team. It's still, as you can see, it's still technically in beta. Yeah, that's just because they're trying to make this thing bulletproof, and it's not bulletproof yet. So, and bulletproof by Google standards is kind of higher than everybody else's standards for the most part. So, yeah. All right. What questions do we have? What direction should I take with this? I mean, I've sort of done some fast walkthroughs. Zeit, yes, Zeit's awesome. Yes, I have heard of Zeit. I'm actually learning Next.js. I was learning it this morning. So yeah, I would host on hosting rather than Zeit. But you could host on Zeit, it would be fine. There's no reason you can't use other things. You can mix and match all of these. Literally, I would use authentication with Zeit, with any other hosting provider. I would still just use Firebase authentication because it's free and it's easy. It's just a few lines of code. I mean, you don't get any better than that. So I've never seen it. I mean, there's Auth0, there are some other competitors, but this is just killer and it's completely free, which is ridiculous. they give these things away to get you on the Google platform. Because once you're on the Google platform, like I spend a couple $100 a month on the Google platform, buying storage from them, running my business through them. I don't spend on authentication. I spend like $10 a month on the database stuff. All the stuff I run is under $10 a month. Same with storage. But then I do pay for some other stuff, some more advanced features that I use. So they're just trying to get people on the platform, which is why it's so cheap. They just want developer mind share, want us all using as much as possible. Yeah, you can definitely track page views. It's a static. So hosting is static. For the most part, there's one exception to it, that you can make things dynamic. But yeah, you can definitely put analytics on your page. No problem. Yeah, hosting is pretty straightforward. The one piece of dynamic thing you can do with hosting is you can do a redirect to a cloud function. So take a path like /hello world, and you can redirect hello world at your domain. So chrisesplin.com/hello world, I can redirect that to this cloud function. And that lets you do some really, really fancy stuff. I don't really like talking about or covering it too much because it's really advanced. And there's no reason you should be doing this right out the gate. Like it could get you more confused than do good, but you can do this sort of redirect to a cloud function, which when it just enables some really cool stuff. And I'm trying to work on some new models of how to develop for that. Yeah, they have a ridiculous free tier. Yeah. So Firebase is definitely Google's answer to AWS. Firebase is Google they're just trying to get back in the game. So in terms of market share, AWS and like Azure are huge. Azure is enormous. Microsoft makes their money off Azure now. So Azure's huge. AWS is like in first or second place. I don't even know if they're first place anymore. IBM is oddly big, but just for like big corporations, not for developers like us. I've never met a developer like us who uses them. Like web guys, we don't use IBM. And Google Cloud's trying to bump up there. I think they're in like third or fourth place now. So what they're doing is they're competing really heavily on price. So they've got really cheap stuff, as you can see with Firebase, and their platform is brand new. So AWS is over 10 years old. So you can kind of tell when you're on AWS that it's older, and some of their APIs just feel older. They've got some old patterns, some things we don't do in JavaScript anymore. Their SDK kind of does. So Google has competed very heavily on developer experience and price. Yeah, Hugo and Markdown. Yeah, that's good. You can definitely host that. Very easy to host on it's static, right? So you just throw it up on Firebase hosting. You just say Firebase deploy hosting, and it's up. And it'll go right up, and you're done. IBM Cloud is weird. I don't know. Like I think we could probably use it if we wanted to. I'm sure they've got stuff I could use, but they don't market to developers like me. I've never seen advertisements for their stuff. So I assume they're selling into big corporations. Probably, like you say, Spring Boot, Java stuff. Yeah, so they're probably I just imagine they're less sort of JavaScript web friendly. That's not really their target market. Yeah. And Azure, of course, sells deep into the Windows environment, the Windows development, the C# world. And they've done very well there, of course. They're Microsoft. And so I feel like in the open source world, we're all fighting over AWS versus Google Cloud Platform, going back and forth between the two of those. And each one has different features that are better for different things. So it's kind of neck and neck. You'll see news stories about companies moving to Google Cloud Platform, GCP, because they're really fighting hard to get companies to move over. Who was it? GitLab just this week announced that they're leaving Azure for GCP. Yeah. So, oh yeah, one more thing I wanted to say. So Firebase is Google Cloud Platform. It is GCP. everything you see in Firebase, like this is all running on top of Google Cloud Platform infrastructure. So it's just a skin on top of Google Cloud Platform stuff to make it easier for developers like us to use it. So if you need, so everything, like you can do anything with Google Cloud Platform. They've got an enormous offering meant for big corporations. Like it's a big, big thing. But they recognize, when they bought Firebase, they recognize that developers in the open source community and people just getting started working on smaller projects, we don't necessarily want the overload of Google Cloud Platform. Like let me show you. Let me show you like one of my Google Cloud projects. I got a ton of them. And every Firebase project is also a Google Cloud project. So if you look under the hood, you can see stuff running under here. Let's see if I can find one though. It's different user account. Shoot. Shut that down. So here's the nav menu. So there's Cloud Functions, there's Kubernetes Engine, there's Cloud Compute. Like this thing is a monster. Big data, BigQuery, PubSub, all these things. So you can do anything with this, but you don't always want to do everything. Sometimes you want to have a nice experience and just have it all packaged up pretty and nice for you. And so when they want to package something up really pretty and nice, they put it under the Firebase brand. So everything under here is like tied up with the bow. Like here's this really cheap or free feature you can use, and it'll get all this work done for you and enjoy. And it's their tease to get you onto the main platform. TensorFlow is separate, but you can do stuff like that. They've released some, like I said, tied up in a bow versions of that for Firebase. So MLKit is their machine learning thing, and I think it's only, I don't know if you can use it. I don't think you can use it for web. I think it's only for Android and iOS, but I could be wrong. These tabs here, these are the Android and iOS stuff. So stability and analytics, that's all Android, iOS, and grow. This is Android, iOS stuff. We don't get to use that. So I work in 1, 2, 3, 4, 5 tabs at the top to develop. These are the old school web tabs before they decided to make everything Android, iOS, and fancy. Okay, 2 questions. So one is decentralized web, like 10 years out, serverless apps and persistence. Yeah, that's really cool. I do full serverless now with Firebase. So this, with Cloud Functions, 100% serverless. The whole point of Firebase is to go serverless, to use the exact same Firebase infrastructure for your Android, iOS, and web apps. It's the exact same thing. You should be able to just roll to all those platforms. And if you use Cloud Functions correctly, it's completely serverless. Yeah, I've not looked into decentralized web or crazy stuff like no, I haven't done that. And yeah, started to like Go more than JS. A lot of people do. Yeah. And a lot of the Google people like Go more than JS. And so they actually have a bunch of Go support for Firebase now because the internal Google groups, Google people want to use Go. So yeah, if you're not doing web front ends, yeah, use Go. Pluralsight uses .NET for a lot of our backend, but a lot of Node, frankly. I work on a Node and React team. So yeah, serverless is, oh man. So the point of serverless is they're still servers. And this is the problem with serverless. It's a misnomer. Like you say serverless, oh, there are no servers. No, there are a lot of servers. They're just really sophisticated servers that somebody else is managing, not me. And even better, I don't have to write any like Express or Node routing or any of that stuff to use these services. These services exist for my client to talk directly to them. So my client app, my web app, my Android app, my iOS app can talk directly to a cloud function. And that cloud function can respond with whatever, like this hello world example. Now, this thing has been sitting up on their infrastructure since like May 20th or something like that. Since the last time I worked on this particular demo. And it's just been sitting there quiet, waiting. I haven't paid a dime for it. And if 1 million people hit it today, it serves 1 million. So that's the difference, is I don't have to have servers spinning in the background all the time. I don't have to manage that. They're spinning them up, spinning them down, doing all the leveling, all the node balancing. And you can do that yourself if you're really sophisticated. But I'm not that sophisticated. I'm not that good at that kind of stuff. That's hardcore DevOps kind of stuff that I don't do very well. So I outsource all my DevOps to the Firebase guys and say, this is your job. You do it. I will just write some code, and my hello world will run when it needs to. So yeah, serverless is moving toward this. The future, I feel like the future is serverless. The future is us writing individual functions that run on their own and scale on their own. So the big problem, there are 3 levels of this. There's the monolithic web application where I write like a big .NET or Java Spring Boot app, do it in Node 2, write a big app that encapsulates all of my functionality. And I put this app up on a server, and the server just listens for requests and responds to them. It's just one big application. It's called a monolithic web app. It's like a Pluralsight. We started off with a monolithic web app. We still have what we call the monolith. And we're trying to extract services out of the monolith and get them out of there. Because what happens with a monolithic web app is you have to scale the whole thing up and the whole thing down. So now you get enough requests. Now you need 2 monoliths, now 3 monoliths, now 4 monoliths. And the whole thing sort of has to scale. It's kind of tricky. Also, the code bases, because they're all a shared code base, you can make calls across classes within the code base. And the different classes, while it's nice that you can make these shortcut calls, they become what's called coupled. So every part of the app is tied to every other part of the app, and you can't easily extract apart. So if you find out, so let's say, so this is a story from Pluralsight. We did a big giveaway at like a big Microsoft conference and gave away a whole bunch of free Pluralsight stuff to Microsoft people. So Microsoft announces this in front of their 100,000 developers who all go online at the same time and try to hit this one page, just one of our pages, and try to hit one page to redeem their coupons. Well, the one page is being served off the monolith. So now you have 1 million people hitting the monolith, and the monolith just tips right over. Doesn't have a chance. Now, if that had been a page over here, had been a separate instance serving that page up, yeah, maybe this thing would have tipped, but the rest of the app would have stayed up, and your customers wouldn't be out of luck. But because they served it from the monolith, it takes the monolith down. The whole thing fails. You get these really nasty dependencies. So that's a monolithic web app. It's the fastest way to develop because everything's a shortcut. Everything's contained. It's really easy to think about. And for a lot of apps are still monoliths. Like there's nothing inherently wrong with a monolith, but most people extract monolith code into what we call microservices, which is like one service for the email, one service for the login, one service for this, one service for that, and they all live in different places and talk to each other via HTTP. So you got a lot of little APIs. So your app is now a collection of APIs that can talk to each other, and that's microservices. There are a lot of flavors of that. Some people love it, some people hate it. You can still get in trouble with microservices. But what serverless is more along these lines where we just write individual functions, and the function itself, individual chunks can scale up and down. Not even like the email service, but one bit of the email service can now scale up and down. And that's like the best of all worlds in terms of scaling. It runs into trouble because they can be harder to write. But anyway, yeah, microservices, exactly. Like they're just functions. Like maybe 10 lines of code that scales on its own. It's ridiculous. So, great. Fullstackfirebase.com, www.fullstackfirebase.com. If you have any questions, I gave you guys the link to my super secret videos. And hit me up on Twitter or email anytime. I'm super happy to help. So, I think we're out of time.
Awesome. Thanks, Chris, so much for taking the time to sit and chat with our students. I will drop any information that Chris sends me into the Brown Bag channel on Slack. And yeah, so if you have any questions, just hit us up there. We're going to go ahead and end the meeting. I will also be sending out the link for the recording of this lecture. So anyways, everybody have a nice afternoon, and thank you so much. Bye.